The universe. It's a word that carries weight, a concept that has fascinated humanity since the dawn of thought. But what is it really? Is it the stars we see twinkling in the night sky, the galaxies swirling in the depths of space, the invisible forces that bind everything together? The answer is all of that and so much more. The universe is everything that exists, everything that has existed, and everything that will exist. It's the stage on which the drama of reality plays out, and it's a stage so vast that it defies comprehension. To truly understand the size of the universe, we must first understand its history, its structure, and its mysteries. And to do that, we must start at the beginning, or as close to the beginning as we can get. Let's rewind the clock back to a time before time itself. Imagine a point infinitely small, infinitely dense, and infinitely hot. This point contains all the matter and energy that will ever exist in the universe, compressed into a singularity, and then, in an instant, it explodes. Not an explosion in the traditional sense, but an expansion, a rapid exponential stretching of space itself. This is the Big Bang, the event that marks the birth of our universe. In the first fraction of a second, the universe grows from smaller than an atom to the size of a grapefruit. Within minutes, it's the size of a galaxy, and within a few 100 million years, the first stars and galaxies begin to form. But let's not get ahead of ourselves. The early universe was a chaotic, seething cauldron of energy and particles, quarks and gluons, the building blocks of protons and neutrons, swirled in a primordial soup. As the universe expanded and cooled, these particles began to combine, forming the first atomic nuclei. Hydrogen and helium, the simplest and most abundant elements in the universe, were born. But the universe was still dark, filled with a dense fog of gas that blocked light from traveling freely. It wasn't until about 380,000 years after the Big Bang that the universe cooled enough for electrons to combine with nuclei, forming neutral atoms. This allowed light to escape, creating the first glow of the cosmos, a glow that we can still see today as the cosmic microwave background, CMB. The CMB is one of the most important pieces of evidence we have for the Big Bang. It's a snapshot of the universe as it was just 380,000 years after its birth, a faint echo of the explosion that started it all. But it's also a reminder of how far we've come in our understanding of the cosmos. When the CMB was first discovered in 1965, it was a revelation. It confirmed the Big Bang theory and gave us a window into the early universe. Today, we've mapped the CMB in exquisite detail, using satellites like the Planck Observatory to measure tiny variations in temperature that reveal the seeds of cosmic structure, the tiny fluctuations in density that would eventually grow into galaxies and clusters of galaxies. And speaking of galaxies, let's fast forward a few 100 million years. The universe is still young, but it's beginning to take shape. The first stars, known as population 3 stars, are forming from clouds of hydrogen and helium. These stars are unlike anything we see today. They're massive, hot and short-lived, burning through their fuel in just a few million years before exploding in spectacular supernovae. These explosions seed the universe with heavier elements like carbon, oxygen and iron, the building blocks of planets' life and everything we know. As the universe continues to expand and cool, gravity begins to pull matter together, forming the first galaxies. These early galaxies are small and chaotic, but over billions of years they grow and evolve, merging with other galaxies to form the majestic spirals and ellipticals we see today. Our own galaxy, the Milky Way, is the product of countless such mergers, a cosmic tapestry woven from the threads of ancient stars and galaxies. But the Milky Way is just one of billions of galaxies in the observable universe. To get a sense of the scale we're dealing with, let's take a step back. Imagine the Milky Way as a grain of sand on a vast beach. Each grain of sand represents another galaxy, and the beach stretches as far as the eye can see. Now imagine that this beach is just one of countless beaches on an endless coastline. That's the universe. It's a place of unimaginable scale, where galaxies are the building blocks of cosmic structure, and where the distances between them are so vast that they're measured in millions or even billions of light years. And yet, even this is just the observable universe, the part of the cosmos we can see from Earth. The actual universe might be much, much larger. In fact, it might be infinite. But how can we know? How can we measure something that might have no end? The answer lies in the geometry of space itself. According to Einstein's theory of general relativity, the universe can have one of three possible shapes: flat, open, or closed. A flat universe is infinite, with no boundaries and no end. An open universe is also infinite, but it curves outward like a saddle. A closed universe is finite, curving back on itself like the surface of a sphere. So, which is it? The answer, as far as we can tell, is that the universe is flat. Measurements of the CMB and the large-scale structure of the universe suggest that space is neither positively nor negatively curved. It's flat. This means that the universe is likely infinite, stretching on forever in all directions. But infinity is a hard concept to grasp. It's not just a very big number. It's a concept that defies intuition. If the universe is infinite, then it contains an infinite number of galaxies, stars and planets. It means that somewhere out there could be an infinite number of Earths, each with its own version of you, living out every possible variation of your life. It's a mind-boggling idea, but it's one that's supported by the best evidence we have. But let's not get lost in the abstract. Let's bring it back to something tangible, something we can see and measure. Let's talk about the Hubble Deep Field. In 1995, the Hubble Space Telescope pointed its camera at a tiny, seemingly empty patch of sky and took a long exposure. The result was one of the most iconic images in the history of astronomy, a picture filled with thousands of galaxies, each one a swirling island of stars, gas and dust. Some of these galaxies are so far away that their light has been traveling for over 13 billion years, giving us a glimpse of the universe as it was just a few 100 million years after the Big Bang. The Hubble Deep Field is a reminder of just how vast the universe is. It's also a reminder of how much we still have to learn. Every galaxy in that image has its own story, its own history, and its own mysteries. And every one of those galaxies is just a tiny piece of the cosmic puzzle. But the Hubble Deep Field is just the beginning. In the years since that first image was taken, astronomers have used increasingly powerful telescopes to peer even deeper into the cosmos. The James Webb Space Telescope, launched in 2021, is now taking us even further, revealing galaxies that formed just a few 100 million years after the Big Bang. But the universe isn't just big, it's also dynamic. It's a place of constant change, where stars are born and die, where galaxies collide and merge, and where black holes devour everything in their path. Let's take a closer look at some of these cosmic phenomena, starting with stars. Stars are the engines of the universe, the factories where elements are forged and energy is released. They come in all shapes and sizes, from tiny red dwarfs that burn for trillions of years to massive blue giants that live fast and die young. When a star runs out of fuel, it doesn't just fade away, it goes out with a bang. Massive stars end their lives in supernovae, explosions so powerful that they can outshine an entire galaxy. These explosions scatter heavy elements into space, seeding the universe with the raw materials for planets, life, and everything we know. But not all stars go out with a bang. Some, like our Sun, will end their lives as white dwarfs, slowly cooling over billions of years. Others, more massive than the Sun, but not massive enough to go supernova, will collapse into neutron stars, incredibly dense objects where a teaspoon of material would weigh billions of tons. And then there are black holes, the most mysterious objects in the universe. Black holes are regions of space where gravity is so strong that nothing, not even light, can escape. They're formed when massive stars collapse at the end of their lives, or when two neutron stars merge. But black holes aren't just cosmic vacuum cleaners, they're also engines of creation. When matter falls into a black hole, it heats up and emits intense radiation, powering some of the brightest objects in the universe, known as quasars. And at the center of almost every galaxy, including our own, lies a supermassive black hole, millions or even billions of times more massive than the Sun. But the universe isn't just about stars and galaxies, it's also about the invisible forces that shape them. Dark matter, for example, is a mysterious substance that makes up about 27% of the universe. We can't see it, we can't touch it, and we don't know what it is, but we know it's there because of its gravitational effects. Dark matter holds galaxies together, and it forms the cosmic web that structures the universe on the largest scales. Without dark matter, the universe as we know it wouldn't exist. And then there's dark energy, the even more mysterious force that's causing the universe to expand at an accelerating rate. Dark energy makes up about 68% of the universe, and we know even less about it than we do about dark matter. Is it a property of space itself? A new kind of field or particle? We don't know, but we do know that it's shaping the fate of the universe. If dark energy continues to dominate, the universe will keep expanding faster and faster, eventually leading to a big freeze, where galaxies are so far apart that the universe becomes a cold, dark and empty place. But that's just one possible fate for the universe. Another possibility is the Big Crunch, where the expansion of the universe slows down and reverses, causing everything to collapse back into a singularity. Or there's the Big Rip, where dark energy becomes so strong that it tears apart galaxies, stars and even atoms. We don't know which of these fates awaits the universe, but we do know that the answer lies in the nature of dark energy, a mystery that we're still trying to unravel. So, how big is the universe? The truth is, we don't know. The observable universe is about 93 billion light-years across, but the actual universe could be much larger, perhaps even infinite. And if the universe is infinite, then it contains an infinite number of galaxies, stars and planets. It means that somewhere out there could be an infinite number of Earths, each with its own version of you, living out every possible variation of your life. It's a concept so vast and strange that it defies comprehension. But perhaps the most astonishing thing about the universe is not its size, but the fact that we can even begin to understand it. We are tiny, fragile creatures living on a speck of dust in an unimaginably vast cosmos, and yet we have the audacity to ask questions about the nature of reality. We have built telescopes that can peer billions of light-years into space, and particle accelerators that can recreate the conditions of the early universe. We have developed theories that explain the behavior of galaxies and the birth of stars. And we are constantly pushing the boundaries of our knowledge, seeking to unravel the mysteries of the cosmos. So, the next time you look up at the night sky, take a moment to appreciate the sheer scale of what you're seeing. Every star, every galaxy, every flicker of light is part of a story that began 13.8 billion years ago and continues to unfold every second. The universe is vast, mysterious and beautiful, and it's ours to explore. And who knows, maybe one day we'll find the answers to the biggest questions of all. How big is the universe, really? And what does it mean for us? Until then, let the wonder of it all fill you with awe. The universe is bigger than we can imagine, and yet, in some strange way, it's also a part of us, We are made of stardust after all, the remnants of ancient stars that lived and died billions of years ago. We are the universe contemplating itself. And in that contemplation we find not just answers but a sense of connection to something greater than ourselves. So go ahead, let your mind be blown. The universe is waiting,